Hello, class. Coming back to you today. I wanted to pick back up with long division. I plan to do another long division problem, and then we'll talk about another type of division known as synthetic division, and then we will also look at the remainder theorem as well as the factor theorem. So let's jump back. I'm going to share my screen. Let's jump back into long division. I just want to go back to number 11 and 12. Let me share my screen, share my document camera. Okay, so what we have here is number with long division, number 11 and 12, where basically the problem has been pretty much started for us on both of these, and we're asked to complete them or uh, list or name the next step that we would have to do. So with number 11, let's take a look at it. So it says in the following long division problem, the first two steps have been completed. So we've got our dividend under the rooftop, and we've got our divisor here. So our dividend is 6x squared plus 9x minus 3, and we are dividing that by 3x minus 7. So remember, the first step is to divide the first term by the first term. So that's been done for us. They divided 6x squared by 3x, okay, which left us with 2x. And then the second step is to multiply that answer from step 1 by the entire divisor, which would give us back the 6x squared minus 14x, okay? And then the third step would be to subtract that product. When we multiply that 2x times that whole divisor, we would subtract that product from the corresponding like terms of the dividend. So it says the next step is to subtract. What we would do is right here, subtract that polynomial. Okay, so that means when we're filling in these blanks, it says the next step is to subtract 6x squared minus 14x from 6x squared plus 9x. That's what we would subtract. And if you needed to see that done, of course, I recommend having paper. When you're working through these problems, it's almost impossible to work through these problems on the computer without writing them down, okay? So when you're working through it, you take that minus through, and so it changes that to a negative, and it changes this to a plus, and you carried it through. So when you subtract 6x squared minus 14x from 6x squared plus 9x, you actually end up with 23x. The 6x squareds cancel, and 9x plus 14x gives us 23x, which would go here. And then after the subtraction, you would bring down, because that would be placed right here, and then you would bring down that next term. Then bring down the negative 3, and that forms a new dividend, which is 23x minus 3. Okay, so I felt it would be a little easier if you saw the steps worked out, if we actually worked through them, first, and then came back to that one or to number 12 and determine what the missing step was from that problem. Because here they're working it out for you, and it may be hard to actually visualize what the next step is without having done it. Okay, so that was my process. That was my thinking as far as skipping over number 11 or number 12 for that matter, and then coming back to that. Okay, number 12 is a similar problem. It is pretty much worked out. Most of the steps have been completed, and then you are asked to determine what that last step is, completing that last step. So right here, it looks like completing the step designated by the question mark obtains. So here we are going to subtract. Okay, remember you haven't subtracted until you put that polynomial in parentheses and put a minus out there. And then you take that negative through. So it would change the sign here, and it would change the sign here, okay? And so what happens is 14x and the minus 14x cancel, and then you've got 3 plus 21, which gives you 24, okay? So completing the step, right here I'm reading, completing the step designated by the question mark obtains 24. Thus, the quotient is 3x minus 7. And the quotient is what sits on top of the housetop here. And the remainder is the 24, because there's nothing else to bring down. So you're at the end of the problem. Okay. All right. And then it just says the answer to this long division problem. This is where you would actually write everything in. Of course, I don't have enough room for this blank. You would write the quotient, and then you would say plus the remainder over the dividend. And that whole thing would be your answer. Okay? So long division is, again, when you're dividing long division, dividing polynomials by long division, it is essentially the same steps for long division of just basic numbers, what we learned in arithmetic. It's just we have a few added, I guess, little properties, I guess you can say, because it is dealing with variables. But divide, multiply, subtract, bring down next term, okay? All right, so let's move on. I'm going to take the problems away for a minute and put back the notes. Okay, so remember we said we're looking at long division. We're also going to look at synthetic division. So let's talk about synthetic division now. Okay, all right. So synthetic division is basically a shortened method for long division, as long as the divisor is of a certain form. Now, if the divisor is not x minus c, if it's not of this form, and this could be x plus or minus c, of course, but what I mean is the coefficient in front of the x for your divisor has to be 1. The constant can be plus or negative. But as long as your divisor is of this form, then you can use synthetic division. If, for example, let me go back here. Remember we did number 14, long division. You couldn't use synthetic division on this one. We had to do long division on here. But number 13, we could have actually used synthetic division on this one because look at the divisor. Remember, the divisor is what you're dividing by. So as long as it's of the form x plus or minus a constant, you can use a shortened version of division. You can use the synthetic division. But if it looks anything like that, no, okay? So synthetic division, the steps that we'll perform, we will arrange the polynomial in descending powers, okay? That is the polynomial that we are dividing into, okay? That is your dividend. Okay, we're going to arrange the dividend. Maybe I need to put that here. So when I'm talking about the polynomial, dividend is what I'm referring to. We're going to arrange the dividend in descending powers with a 0 coefficient for any missing term. So that means every term has to be represented. So if it jumps from x cubed down to x squared, no, if it jumps from x cubed down to x, that means the x squared term is missing. You got to put in a 0 there, okay? And I'll show you as we walk through it. So we'll arrange the polynomial, the dividend specifically, in descending powers. With any missing terms, we'll have a 0 in its place. We will write the c for the divisor x minus c to the right, and we'll box it off. We'll write it to the right of the coefficients of the dividend. We'll write the leading coefficient of the dividend on the bottom row. So basically we'll bring it down. We'll start there. So we have to have a starting point. So we'll just drop it down. And then we will multiply the constant c times the value just written on that bottom row. That leading coefficient that we brought down will start by multiplying the c times it. And then we'll get that product and we'll put that in the next column of the second row. And I understand that these steps may not make a lot of sense until you see them, but it will be clear when you see them, okay? So that's step number 4. Then step number 5, we'll add the values in the new column by writing the sum in the bottom row. And we'll just kind of repeat these steps. We'll repeat the series of multiplication and additions until all the columns are filled in. And that the numbers that we have on that bottom row, that last row, that is what we use to create the quotient, to create the answer. And then, of course, plus the remainder. So it'll be the quotient plus the remainder, which will be written above the divisor. The degree of the first term of the quotient should always be 1 less than the degree of the dividend, of the first term of the dividend. Okay? When you get that row, that last value at the end is the remainder. Okay? Let me walk you through it. I promise it'll make sense. Okay, so actually what I may do before we look at homework, let's look at this problem. So here's one in the notes. It says use synthetic division to divide x cubed minus 7x minus 6 by x plus 2. So this is my dividend. Notice that the dividend jumped from x cubed down to x to 7x. So it's missing the x squared term, okay? The divisor is of the form x plus or minus c, so we're good there. But because it's a plus, we're going to take the opposite of C. That means C has to be negative. Because remember, initially it needs to look like X minus C. But if we've got an X plus C, that means your C has to be negative. So we'll basically, in other words, take the opposite of that sign. So if you were looking at this for long division, this is what it would basically look like. You would have your divisor here, and you'd have your dividend under the housetop, the rooftop, okay? So when we get ready to perform synthetic division, I'm going to write it down right here, and then I'll flip it over. I'm going to take the opposite of that C term, so I'm going to box off the -2 right here, and in a row right beside it, I'm going to place the coefficients of my dividend. So my leading coefficient is 1. Remember, it jumped from x cubed to x, so I'm missing the x squared term, so I'll have a 0. Notice that we have a 0 right there because it went from x cubed to x squared to x and then to 6, the constant. So I have to show that missing term. Then the coefficient for the x term is a -7, and then I have my constant. Okay, so I take the coefficients of my dividend, I put them in a row. Remember to include zeros for any missing terms. And then to the left of that, I box off the constant and make sure I use the opposite sign of what I see from the divisor. The constant from the divisor, I take the opposite sign. It was +2, so I use a -2. And that is again because it was supposed to be of the form x minus c. So if I have x plus c, that means c had to be negative. I take that and I kind of save a little room, creating an empty row space, and I put a plus here, and I drop down my leading coefficient. I start there, okay? So that's where it would begin. So I'm going to flip it over, and you'll see that written on this other page here, okay? Now, I'm going to rewrite what I just had. I'm going to have the -2 boxed off, and I've got 1, 0, -7, 6. And I saved some room here. I put my plus because I'm going to be adding, but I start off by dropping down that first leading coefficient. So I want to show you where these 3 numbers come from. They're just kind of filled in here. I want to show you where they come from. So I drop down that leading coefficient because I have to have a starting point. Then I say -2 times 1. That gives me a -2. I put that -2 in that second column. And notice that I wrote a plus here because I'm going to be adding to bring down the next term. So 0 plus a -2 gives me a -2. Then I say -2 times -2. That gives me a +4. I put that 4 in the next column. And then I say negative 7 plus 4. That gives me a negative 3. Okay. Then I say negative 2 times negative 3. That gives me a positive 6. And I accidentally left off that negative right there, so I put it in. So negative 2 times negative 3, that gives me a positive 6. So negative 6 plus 6, that gives me 0. Okay? That last number at the end is always the remainder. Okay? Now, keep in mind that your dividend had a highest power of x cubed. Remember, it was x cubed. So your quotient will be 1 less power. Its degree will be 1 less power than what your dividend was. So if the original polynomial, the dividend was x cubed, that means this is the coefficient now for x squared. This is the coefficient for x, and this must be the constant here. So our quotient, our answer, when we form it, is 1x squared minus 2x minus 3, and we had a remainder of 0. Okay, we had a remainder of 0. So I'm going to look at some more problems in the homework now. Okay, so I'm going to take that off for a minute. Let's look at number 15 here. Remember we did 13 and 14 in the first video, long division. Let's look at number 15. So I'm going to zoom in a bit here. Number 15, it says use synthetic division. So here is our dividend, here is our divisor, okay? Looking at our dividend, we have no missing terms. It goes from x squared to x to the constant. So it's in descending order with no missing terms. 2, exponent of 2, exponent of 1, exponent of 0, or nothing, just the constant. And then I've got my divisor. It's of the form x minus c. So I take my constant and I take the opposite of what I see. I see a minus 2, so I take a positive 2. Okay? And then to the right of that constant from my divisor, this is the constant from divisor, just so that you're aware. Okay? That's what that is. The opposite sign, I should have said. Let me put opposite sign. Because notice that was a minus 2, but we take a plus 2. If it had been a plus 2 here, I would have said a minus 2 or a negative 2. All right, so that's the opposite sign of the constant from the divisor. Then I take the polynomial, the dividend, and I write the coefficients from its terms, or the coefficients of its terms. So 9, 1, 0. I'm sorry, not 0, negative 38. 9, 1, negative 38. So the coefficients as well as the constant term. I'm going to save some space here. Put a plus there, but I always drop down that first term. I got to have a starting point. Okay? So I say 2 times 9. I'm putting a little dash here so that you kind of just see where that comes from. So I say 2 times 9. That's 18. Okay? Then we say 1 plus 18. That's 19. Okay? Then 2 times 19. That gives us what? 38. And then we say negative 38 plus 38. That gives us 0. So that last spot will always be your remainder. Okay? So we have a remainder 0. And remember, you're going to now take these coefficients as well, the coefficients and the constant to form your divisor. Remember your dividend started with a power of 2. So your divisor will be 1 less power. So what's below, what's 1 power less than x squared, it would be just x. So this 9 will be the coefficient of the x term, and therefore this will be the constant, because after x, it would just be the constant. That's why it's important to put them in descending orders and also to fill in any missing spots with zeros. So you have for your quotient, you have 9x plus 19, and you had a remainder of 0. So this would just be your answer. If you had a remainder, if it was anything other than 0, then you would express it as plus the remainder over the divisor, just like we did up here with long division. But there was no remainder, so our answer is just 9x plus 19. Okay? I'm going to do another one. There are a couple of these actually, number 16, number 17, so we're going to do both of those. And then we'll look at synthetic division. I'm sorry, that is synthetic division. But we'll look at using synthetic division and the remainder theorem. So more so focus on the remainder theorem to find this function value, okay? So look at number 16 now. It says divide using synthetic division. Our dividend is 2x squared plus 5x minus 3, and we're going to divide that by x plus 5, okay? So looking at the dividend, first off, are there any missing terms? No. It goes from x squared to x and then to your constant. So no missing terms. Your divisor is of the form x plus or minus c, so you're good there. So you're going to take the constant from the divisor, the opposite of what sign you see. So that was a plus 5, so we take a negative 5. And then we write in a row beside it the coefficients and the constant term of the dividend. So 2, 5, negative 3. I save some space here, put my plus, and I bring down my leading coefficient. I have to have that starting point, okay? So now we say negative 5 times 2, that is a negative 10. Then we place that negative 10 in the second column so that we can add 5 plus negative 10, which is a negative 5. Then we say negative 5 times negative 5, which is a positive 25. And we place that answer in the next column, and we say negative 3 plus 25, that is 22. That last spot is always, always the remainder, okay? Always, always the remainder. So if your dividend started with x squared, your quotient must begin with one less power. So the power right below x squared would be x. So that makes this the coefficient of the x term, and therefore this has to be the constant. If you think about it in reverse, remainder, constant, x squared, x cubed, x to the fourth, if you wanted to think about it going in that direction. But basically, you're just writing your quotient, your answer, using these numbers now that are there. And so just keeping in mind, when you perform division, you're reducing the highest power of the dividend by 1, okay? So if the power for the highest power, the degree of the dividend was squared, then your answer, your quotient, its highest power is x. Had it been x cubed, then it would have been x squared. I think we may see that in the next problem. So our quotient would be 2x minus 5. Our remainder is 22. So our answer, our full answer that we'll enter in will be 2x minus 5 plus 22 over x plus 5. You always write the remainder over the divisor. I'm going to write that down. Write remainder over the divisor. Okay? That is synthetic division. So again, I brought down the first term, said negative 5 times 2. They gave me negative 10. I put that in the next column right here. Added and I got -5. Then I said -5 times -5. They gave me +25. I put that in the next column here. I add, they gave me 22. And then that was the end because there was no other row, no other column. Okay. All right, let's look at number 17. Let's do one more. And then we'll look at the last two theorems. Oh, yeah, we're going to definitely do number 19. I'll show you that one as well. All right, let's look at number 18. One more number 17. One more synthetic division. So it says divide using synthetic division. So again, this is your divisor. This is your dividend. Take a look at your dividend. Your exponents went from x to the 5th to x to the 3rd, x squared, x, and then your constant. So right here, we are missing x to the 4th. So we got to plug that in. We got to have that missing term. So I'm going to write that again as 3x to the 5th plus 0x to the 4th minus 5x cubed plus 5x squared minus 4x plus 4. So I wrote it with the missing term first so that you would see where it's coming from, okay? So the missing term, that x to the 4th was missing. So I wrote that. I rewrote the dividend with that missing term. Now I'm ready to set up the synthetic division, okay? So to set up the synthetic division, I take the constant term, the opposite sign of what I see, and I box it off. So that's a -2, so I take a +2. Then, I'm going to scoot this up some. Then I take the coefficients of my dividend. So my coefficients are the numbers in front of the variables. So 3, 0, -5, 5, -4, 4. I save some space, put my plus, and I bring down that first term there. I have to have my starting point. Okay? Now I say 2 times 3. That gives me 6. I put 6 in the next column because I need something to add here to that 0. So 0 plus 6 gives me 6. Okay? Then I say 2 times 6. Well, 2 times 6 gives me 12. I put 12 in the next column. And then I add here, -5 plus 12. What is that, 7? Okay. Then I say 2 times 7. That's 14. So I put 14 in the next column. 14 plus 5. That is what, 19? Bring my calculator out when I need it. That's 19. Okay. Then I say 2 times 19, which is 38. I put that in the next column. -4 plus 38, that gives me 34. Then I say 2 times 34, show that here as well. That gives me 68, and I place that in that last column. 4 plus 68 gives me 72. Okay? That last number is always the remainder. Always, always the remainder. Sometimes it's 0, sometimes it's not. In this case, it's not 0. All right, now think about it. If you go in reverse, before the remainder, this must be the constant. This must be C, okay? That then means this is the x coefficient. This must be the coefficient of x squared, of x cubed, of x to the 4th. Because remember, your new answer, your quotient, will be 1 less degree than your original dividend. So your highest degree in your dividend was x to the 5th. That means this is the coefficient of x to the 4th. This must be the coefficient of x to the third. This must be the coefficient of x squared. And then this must be the coefficient of x. So x to the fourth, x cubed, x squared, x, and then our constant. So our quotient and remainder together is 3x to the fourth plus, because it's a positive 6, so we say plus 6x cubed plus 7x squared plus 19x plus 34, and then plus our remainder of 72 over x minus 2. You always express your remainder over your divisor. Because in other words, you're saying, if I could, I would divide 72 even further by x minus 2. But I can't, so I just express it as a fraction, as a ratio of 72 over our divisor. And so this whole thing is your answer, okay? Just takes a little practice looking at the steps and walking through them, okay? All right, so that wraps up synthetic division, but it is linked to another topic, a particular theorem called the remainder theorem. So I want to look at that. Which basically just tells us something about the remainder value. So here's the remainder theorem. It says if the polynomial f of x, which is your dividend, of course, your polynomial dividend, if the polynomial f of x is divided by x minus c, then the remainder, the value of the remainder, is the same as just the function evaluated at c. So in other words, if we were looking at this particular problem here, okay, if we were looking at this particular problem, that 72 would actually just be the same or be equal to this polynomial evaluated at 2, at that number. So f at 2 would equal 72. That's what we're saying. That's what the remainder theorem says. So in other words, you could take, if you were interested in finding the remainder of this particular polynomial function, you could take the opposite sign of what you see, of course. You could take the function and evaluate it at that number, and it would actually give you or produce the remainder. I'm going to verify it for you. So here on number 17, our original function, we filled in the missing term there. So there's really no reason to show it when you're applying the remainder theorem. But we could evaluate f of x, which is 3x to the fifth. Let me scoot this up some. 3x to the fifth minus 5x cubed. So basically just this right here, but I'm just disregarding the 0 term because there's no reason to show it. Plus 5x squared minus 4x plus 4. And so I'm just going to verify that when I evaluate this function at 2, that I get that remainder value. So I'm going to say f at 2. So 3 times 2 to the fifth minus 5 times 2 cubed plus 5 times 2 squared minus 4 times 2 plus 4. So I'm plugging in 2 wherever I saw an x. And I'm going to evaluate it and see if I get that remainder. And I should. That is what the remainder theorem says. Again, the remainder theorem states from the notes, if the polynomial f of x is divided by x minus c, then the remainder is just f at c. So this right here is 3 times 32. So I'm just evaluating the exponents there. 3 times 32 minus 5 times 8, because 2 to the third is 8, plus 5 times 4, and then 4 times 2 is 8, and then plus 4. So all I did so far was evaluate the exponents. 2 to the 5th is 32, 2 to the 3rd is 8, 2 to the 2nd, or 2 squared, is 4. I still have to multiply by 3 here. I'll still multiply by 8 here, and I'll multiply the 5 and the 4 there, okay? So 3 times 32, that's 96, minus 40, 5 times 8, plus 20, minus 8, plus 4. So now I'm just going to put all that in. 96 minus 40 plus 20 minus 8 plus 4. And I get 72. And you just verify that the remainder, when you do the division, the remainder was 72, which is equal to the function evaluated at 2, which was just 72. So that's what the remainder theorem says. Okay? Let's look at a problem related to that, number 18. It says use synthetic division and the remainder theorem to find the indicated function value. So basically, they're telling you you could verify these processes. You could perform the synthetic division by saying this is the polynomial function, and we're going to divide it by, let's say, x minus 1. Or just simply evaluate the function at 1, because that's what I'm going to do. I'm just going to evaluate the function at 1. So where I see x, I'm replacing it with 1. So f at 1 will be 4 times 1 cubed minus 11 times 1 squared plus 5 times 1, and then minus 4. Okay? So 1 cubed is still just 1. 1 squared is still just 1. And then 5 times 1, that's just 5, and then minus 4. Anything times 1 is still just that number. So that's 4 minus 11 plus 5 minus 4. So 4 minus 11, we'll just put it all in. 4 minus 11 plus 5 minus 4. That gives us a negative 6. Negative 6 is our answer. Okay? That is the remainder theorem. Pretty simple theorem. Just basically just saying the process of synthetic division, as long as the divisors of the form x minus c is the same as just evaluating the function at c. That's all it's saying, okay? All right, there's one more property or one more theorem, and then that will allow us to do number 19. I want to mention that theorem, and then we'll work that last problem there. And I may have another one in the notes that will work prior to that one to kind of help solidify that. So again, that was the remainder theorem. So again, if a polynomial f of x is divided by x minus c, then that just means the function evaluated at c is equal to the remainder. Okay? And then that's verified here. It just says, given the function, use the remainder theorem to find f at negative 1. So if you were to use synthetic division, here is your remainder, and you're verifying that f at negative 4 is that same remainder value. Okay? One more theorem here called the factor theorem. Now we will pick up with this theorem even more in the next section because we'll be just kind of looking at more extensively synthetic division and finding zeros, but we're introduced to it in this section and we just build upon it, okay? So the factor theorem just states, let f of x be a polynomial. If f at c equals 0, then that means x minus c, which we can show as a binomial, which is a binomial, if you can use parentheses, put parentheses around it, is a factor of f of x, okay? So if f at c equals 0, what that means is that c must be a solution of the function. So therefore, if c is a solution, that means x equals c. You can then take the c over with the x, to get a factor. That's what that means. And I'll explain it further with an actual problem. Okay, so if f at c equals 0, then that means x minus c is a factor. Vice versa, if x minus c is a factor of f of x, then f at c must equal 0. Okay, so either direction is basically what it's saying. The reason this theorem is important is because we will be looking for solutions of these polynomial functions, and they may give us one solution and then tell us to use it to find the remaining solutions. Well, if you're given a solution, that means C is a solution. When I say a solution, I'm talking about they give us a C value. That means we're able to write that as a factor and use it to get the remaining zeros, to get the remaining solutions. Okay? So let's take a look at an example here. So look at this problem right here. It says, using the factor theorem, solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0. So I've got f of x equals 15x squared plus 14x squared minus 3x equals 2. I'm not really certain why they decided to move that over. It wasn't necessary. Yeah, I won't do that. But we are given, when I work it out, one of the homework problems, I probably won't do that. I'm not really sure what the reasoning was behind moving that. It wasn't necessary. But anyway, if we're given that this number, this -1 is a 0, then what that means is x equals -1. That means a solution for x, because remember your function is a function of x. So that means if -1 is a 0, is a solution, that means x equals -1. Now x may equal other values besides that, but it definitely equals -1. So if x equals -1, that means we can then take that and create a binomial factor for this function. Right now it's written as a solution. We can take that 1 over with the x and write it as a factor and say x plus 1 equals 0. So now we have created a factor, okay? So that's what we're going with right here. It says this means that f at -1 equals 0. Because f at -1 equals 0, the factor theorem tells us that x plus 1 is a factor. And therefore, we can use synthetic division to divide f of x by x plus 1. And using synthetic division will help us to find the other solutions, okay? It will help us to find the other solutions. So here's what I'm going to do. I'm going to start this problem over just from scratch. I'm going to get some fresh paper here, and I'm going to rewrite it so that you can clearly see the steps completed one by one, where there's no confusion here. So I'm going to rewrite this example, and then I'll work number 19, okay, from the homework. And I'm doing this example specifically over from scratch because 19, it's the only problem like it in the homework, and I want you to have more than just one. So I'm going to take the function. So I'm going to rewrite what they put, and this is just the example from the notes. It says solve 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0 of the equation. I'm not going to rewrite the whole equation. I'm just going to say of the equation. Okay. So I've rewritten that, so I can move that away now. Kind of give me a flat surface here. So given that this is a solution, that means given that x equals -1, because that's what that means. If we're solving this, that means we're solving for x, right? So if -1 is a solution, remember 0 is just another name for a solution. Okay? So if -1 is a solution, that means x equals -1, which also means that x plus 1 is a factor. Okay? That means x plus 1 is a factor. So what I'm going to do then is use synthetic division to find the remaining zeros, which again is just the remaining solutions. Okay? So I'm going to take this one solution and I'm going to box it off, putting it off to the side like that. Remember, I'm just following synthetic division steps. I'm going to look at my equation, my dividend, what I'm dividing -1 into, and I'm going to make sure that there are no terms missing. I go from x cubed to x squared to x to a constant. So I'm good there. So I take my coefficients, 15, 14, -3, -2. X cubed, x squared, x constant. So I have no missing terms. I save some room and I drop straight down with that first term. Uh-oh, dang it, my computer froze. Let me close this out, y'all. I will be back. I'm still going to be here, but I'm just got to stop sharing for just a minute and then reopen my document camera. I don't know why it does that sometimes, but it's okay. Okay. Now I'm going to share again. Technology, technology. Okay. And I'm back. Okay. So again, what I was just saying is I'm taking that given solution that they provided me with, and I'm going to use synthetic division to find the remaining solutions. So I take that solution, that -1, I create a little box separating it from the coefficients and the constant term of the dividend of the equation. Okay. I bring down my first term, and then I start, and I actually think I'm going to use a different color here so that it kind of stands out. And I start my process. So -1 times 15, that gives me -15. I add 14 and -15, that gives me -1. -1 times -1, that gives me a +1. Okay, so right here, I multiplied -1 times -1. That gave me a +1. Then -3 plus 1, that's a -2. Then -1 times -2, that gives me a +2. And I put that in the next column. -2 plus 2, there's my remainder 0. And that's an indicator that yes, this is a solution. Because in order for this to be a solution, in order for this number to be a 0, I had to get a remainder of 0. That means it goes into that equation evenly with no remainder. So that's an indicator that, yes, this is an actual solution. So now I have that one solution. Remember, I'm still looking for the remaining solutions. So now I take this new polynomial that I'm creating from synthetic division, and I'm going to try to solve it. So now, remember, your highest power started out x cubed. That means this is now x squared, or you can think about it in reverse. The remainder, the constant term, the x term, the x squared. So our new equation to solve is 15x squared minus 1x minus 2. That's what we want to solve now, equals 0. And to solve this, you can use factoring if it's factorable. Let me say if possible. Or you can use quadratic formula because it is a quadratic equation. You can always use quadratic formula if it's not factorable. I think this should be factorable. Let's see. So I start with my parentheses to see if it's factorable. Okay, so the different ways to factor 15. We've got what, 3 and 5, 3 and 5, or 1 and 15. Being since this constant term is so small, I'm favorable that it'll be 3 and 5. I'm feeling like it should be 3 and 5. 15 is too big, given that this constant is only 2. So I'm going to use 3x and 5x. Okay? I'm factoring 15x squared as 3x and 5x. Now, here's the thing, though. Your middle term here is a -1. So your inner and your outer terms have to be in the right position so that you only get -1, or so that you get -1 when you add the inner and outer terms or subtract the inner and outer terms. So think about it. The only way to factor 2 is 2 times 1. That's the only way to factor 2, okay? But you need to put them in the right spot so that when you get your inner and outer terms, you get -1. Because remember, factoring is FOIL method in reverse. So inner and outer, okay? And also keep in mind the constant term is minus, so you should have different signs in here. One will be plus, one will be negative. So let's see where I need to place them, okay? 2 and 1. I'm going to put the 2 here. I'm going to put the 1 here. Now, if this is not right, I'll switch them. I'll put the 2 here and the 1 here. I just got to check and see what's correct. This is called trial and error factoring. Factoring by trial and error, okay? So the inner term here gives me 5x. The outer term here gives me 6x. And yes, if I subtract them, I do get 1x. So that works. Now I need it to be negative. So that means I need the 6x to be the negative. So that means I need this 2 to have the minus, and I need the plus to be with the 1. Because that would give me a positive 5x and a negative 6x. Okay? So it was factorable. But remember, the quadratic formula, you could also use it. Opposite of b plus or minus radical b squared minus 4ac all over 2a. So if factoring is not comfortable for you, you can use the quadratic formula. I'm going to show you both ways. I'm going to take this opportunity to just show you both methods. So right now, we solved by factoring, okay? So now that I've got my factors, I'm going to break them apart and set them equal to 0 individually. And I'm going to solve. I took the factors and I'm placing them equal to 0 individually. Excuse me. So I'm going to say -1. I'm going to divide by 3. So x equals a -1/3. That's one solution there. And I'm going to add 2 here. I'm going to divide by 5. X equals 2/5. Okay? So my solutions are -1, because remember they gave us the -1, -1/3, and then positive 2/5. I've got 3 solutions, and they're all real, 3 real solutions. And notice that the exponent was x cubed, which indicates 3 solutions. They don't always have to always be real, but in this case, all 3 of them were real. Don't hesitate to also use your calculator, okay? That's not cheating. We have technology for a reason. Utilize it. So let me also show you how you could have put that equation in your calculator and found, possibly found, keep in mind these are fractions, so it may not have been as clear, but you could have at least determined that they're all real. So if you put the equation in y equals, which is 15x cubed plus 14x squared minus 3x minus 2. Let me get out the glare. And then you hit graph. Oh, keep in mind, I need to probably zoom out a bit, because remember we edited our calculator on a previous problem. So I'm going to create a standard window, number 6, just a 10 by 10 standard window. So I can see that it does cross the x-axis in 3 places. So that does tell me that all of my solutions, all 3 of my solutions are real. However, 2 of them look like they're fractions or decimals, and we know that. We actually know that now, right here with these 2. Sometimes they may all be whole numbers. In this problem, they weren't. But at least I can see that, yes, there are 3 of them, and they are all real. Sometimes you can even zoom in and see if that helps you to see anything a bit better. So there's one solution at -1, and you can see this one crossing here at -1/3. Of course, you can't tell exactly what it is on the calculator, but we already found it. And then this one crossing over here at 2/5. Okay, so zeros, again, are just x-intercepts of the graph. The solutions are just x-intercepts of the graph. Let me also show you, if you're not comfortable with factoring, I can't really tell you how important it is that you get comfortable with it. It's really important, especially if you have to go to calculus after this. Quadratic formula can slow you up a bit. It works, but it's not as fast as factoring if you're comfortable with factoring. But I honestly want you to use a method that gets you to the answer, okay? So I want you to factor because you should know how, but if you can't, you can always use quadratic formula. So let's say I got to this point right here, and let's say I was unable to factor. So I'm going to take that equation and rewrite it. Okay? And again, let's say I'm not comfortable with factoring, or I can't remember factoring very well. So what I do is I identify A, B, and C, and I use the quadratic formula. A is the leading coefficient. It's the coefficient of the x squared term. B is the coefficient of the x term, and C is the constant. Okay? And so I plug in these values, opposite of B, so that would be a +1, plus or minus square root of B squared, which is -1 squared, minus 4 times A times C. So it's going to be a -4 times 15 times -2, and then all over 2 times 15. Okay? And so this is another way to get those solutions. Remember, you already have -1 that was given to us. We're trying to get these 2. So we're going to either use factoring to get them, or we're using quadratic formula. Okay? So I'm going to put a little line here. Just draw a little line to kind of separate there. I need some more paper here. All right, so I'm going to scoop this up. Now I'm going to simplify. So I've got 1 plus or minus square root. -1 squared is 1. Okay. This is -4 or -4 times 15 times -2. So I'm going to put that in my calculator as just take the sign with the 4. Just put it right in as you see it. So it's going to be a +120, okay? So 1 plus 120. And then we have over 30, 2 times 15, okay? All right, cleaning that up, continuing to clean it up. 1 plus or minus square root of 121 over 30. Square root of 121. Well, 121, the square root of 121 is just 11, okay? So we've got 1 plus or minus square root, nope, the 11's gone. The square root of 21 is, the square root of 121 is now just 11, and then over 30. So we've got 1 plus or minus 11. So I'm going to say 1 plus 11 over 30, and 1 minus 11 over 30. Okay. So 1 plus 11 over 30, that is 12 over 30, which will reduce. And 1 minus 11, that's negative 10 over 30, which will also reduce. So our solutions, 12 divided by 30 is 0.4, which we're going to change to a decimal. Let me show you that again. My calculator was hidden. So 12 divided by 30, we're going to press math, okay? And the frac just means we'll take that answer that we just saw in our calculator and it will put it in the lowest terms fraction form. So we're going to press enter now. So it's taking that 0.4, that answer, and it's going to change it to a fraction in lowest terms. So that's where we get 2/5 from. So 2/5 is what 12 over 30 became. So 2/5. And right here, this negative 10 over 30, that became a negative 1/3. So there are your other two solutions by either factoring, let's scoop this up. So by either factoring, we got those solutions, or by using the quadratic formula. I'm gonna zoom out just a bit here so that you can kind of see. And I'll scoot back down some. I'll zoom back in a minute, okay? So again, two options to solve when it is a quadratic equation. You can factor it using trial and error factoring, or you can use the quadratic formula. But do you see how much faster using factoring was? Okay, keep that in mind. All right, so let's look at another example. Let's look at number 19 now. I think that was the last one. I think that was the last problem in the notes that we had. It was. Yeah, it was. So as you can see, the last page of the notes that I gave y'all in class on Tuesday, those were the solutions, the solution set. Okay. And again, the solution in the notes use factoring, but I did want to show you the quadratic formula as well. So let's do number 19, and I think that'll wrap up the video here. Let's do number 19. I got some more paper. Yeah, here we go. And I'm going to move it. All right. So here is number 19. I'm going to zoom back in. Okay. So number 19, we've got solve the equation x cubed minus 13x squared plus 47x minus 35 equals 0, given that 1 is a 0 of that equation or of the function. Sorry about that. It's going to clear up when I move my hand. Okay. So x equals 1 is a 0. That we know, okay? We're told that up front. Now, if x minus 1 is a 0, which again is just another name for a solution, then the binomial x minus 1 is a factor. So x minus 1 is a factor. That's what that means, okay? So what we're able to do is take that 1, box it off, and use it in synthetic division to divide out into this equation. Look at the equation, make sure you don't have any terms missing. You go from x cubed to x squared to x to your constant. So take your coefficients of your terms along with the constant and write them in a row beside that 1, okay? So 1, negative 13, 47, 35, or negative 35. Okay, save some space here, drop down, bring down your first term. Okay, so what we have so far, starting with that 1 that we dropped down, 1 times 1, we get 1, put that in the next column. Okay, negative 13 plus 1, that's a negative 12. 1 times negative 12, that's a negative 12 again. 47 plus a negative 12 is just the same thing as 47 minus 12. That is 35. And then 1 times 35 is a positive 35. Put that in the next column. Negative 35 plus 35, there's our remainder of 0. So we know we did it correctly because we were told up front that 1 is a solution. Therefore, we knew when we used synthetic division, it should have given us a remainder of 0. That's how you verify that, yes, it is a solution, okay? Now, your highest degree for your equation was cube. That means now, for this new reduced equation that you're about to write, its highest degree should be x squared, one below what you started with. So here is your constant, here is your x, here is your x squared. So your new reduced equation that you're going to solve now to get those remaining solutions is 1x squared minus 12x plus 35 and equals 0. That's what you're going to solve now. And I'm going to solve it by hopefully factoring. I'm going to try to factor. And this time the factoring should be even easier than the one in the example, the one from the example in the notes, because at least my leading coefficient is just a 1 here. So when I solve this, using my parentheses, when I get ready to solve this, to factor x squared, I just have x times x. Okay, that's the beauty of having just a leading coefficient of just 1. To factor x squared is just x times x. Then I look at my constant term. I say, well, 35. What are the factors of 35? Okay. This time, because my leading coefficient was just 1, I can go ahead and say, what are the factors of 35 that will add to give me 12? Okay. Why do I say add? Because this is a plus. That means they're going to have the same signs. So they're going to both be negative because that's a minus 12. And so 2 negatives added up will still give me a negative. So factors of 35, there are only 2 that really I'm concerned with, 5 and 7. 1 and 35 won't work. There's no way I can get 12 from 1 and 35. 5 and 7 will work. 5 and 7, or 7 and 5, whichever place you want to put it, because it doesn't matter since the leading coefficient was just 1. You just have x and x, okay? Now, again, the constant term is positive, which indicates that I have like signs, and this tells me what they both are. So they're both minus. And that, again, is verified because the inner, negative 5x, and the outer is negative 7x. Together, negative 5x and negative 7x gives me negative 12x. So my factors, x minus 5 and x minus 7, my product of the two factors is set equal to 0. I can break that product up. I can split those factors apart and place them equal to 0 individually and solve. That's called the zero product property. When a product is placed equal to 0, the individual factors of that product can be placed equal to 0, can be set equal to 0. That's the zero product property, okay? Placing the factors equal to 0 individually. So x minus 5 equals 0, or x minus 7 equals 0. So x equals 5, x equals 7. And my other solution, we were given that x equals 1. So my solution set is is 1, 5, and 7. My solution set. So we use the given 0 and synthetic division to get a new reduced equation that we then were able to solve. And we solved it by factoring. Okay, quadratic formula would have worked here as well. All right, so this video ran even a little longer than the first one. My apologies for having to create 2, but I wanted to be very detailed and give you or work as many examples as I could, and I had to stop recording on the first one. So I hope this helps, and I will see you guys in class soon.